Bismillahirrahmanirrahim. Assalamualaikum and hi everybody. Okay, now I will talk about the introduction to Fourier series. Before we start, let's smile like this. Cheese. Okay, now let's go for the Fourier series. Fourier series is actually a specific type of infinite mathematical series involving trigonometric functions, which is used normally to express periodic function. Okay, so now let's try to understand this definition first. Okay, let's say now I have a function defined as ft, and this ft is a periodic function. Okay, so when the ft is periodic, I can represent this function using Fourier series. And since the Fourier series is a type of infinite mathematical series, so I can say that this function can be defined as a summation of the first term of this function plus the second term of this function plus so on so forth until the infinite term. And if I would like to represent this function, I need also to note that all the terms of these functions consisting of trigonometric function. Okay, so that's the definition for the Fourier series, where I can also write this write this function in terms of this symbol. As we have learned before, this is the symbol for series, right? Where the functions or the terms inside this series is trigonometric functions. And it can start from the first term, let's say the n0, until infinite. Okay, so that is a very brief definition about this Fourier series mathematically. So now let's try to understand it graphically. Okay, so let's say we take one example of a periodic function. Okay, so now let's say I take a square wave function. Okay, so this square wave function is a type of periodic function, right? Okay, because you can see a repetitive cycles of this graph. So now if I like to represent this function using Fourier series, what I expect is I will need to add all the terms or all the functions which are trigonometric so that I can represent this square wave function. So the first term that I can have, let's say like this. Okay, so this is the first term. Then if I have the second term, so let's say I have, this is the second term. Okay, and I put it like this. And if I continue with the third term, say I have this one. Okay, so this is the third term. So what I'm going to do is I will add all these terms until infinite term. Okay, so that I can have one function of this summation. I can have another function which is very similar to this square wave function. Okay, so now let's see the effect of this summation. Okay, so now I start again with the same function that we have before, which is the square wave. Okay, so now what I am going to do now is to superimpose, okay, all the terms that we can have just now. So first, let's say I have the first term like this. So when I superimpose, it will be like this. So it means I only now represent this square wave with only one term. So let's say now I continue by adding more terms inside this function. So now I have this square wave. Okay, then I will consider the first term plus the second term, which it will result to this wave. Okay, approximately. And if I keep continuing, okay, on taking the third term now, so I will superimpose with three terms. So first term like this, second like this, and the third term say like this. If I add these three, I will have something like this. So what we can see now, the function is gradually close to the square wave function. Okay, so it means if I keep on adding and increasing the number of terms inside this function, it will go to very close to the square wave that I have. So it means I have one function which is periodic, and if I would like to represent this Fourier series expansion of this function, then what I need is to identify what are the terms inside this function so that it can be represented as the periodic function that I have originally. Okay, so that's the definition of Fourier series or the description of Fourier series graphically. Okay, so can we see any example of this Fourier series? So this is the example that you can see here. If I have only one term, okay, it will only go to this graph. But if I add these two terms, it will go to this graph, 3 terms and 4 terms like this, as you can see from this animation. Okay, so that is how, okay, we can see the effect of adding up all the terms inside the Fourier series function, inside the Fourier series of a particular periodic function. Okay, now how can we represent a function, or here a periodic function, using Fourier series? It can be done by Fourier series expansion, and the Fourier series expansion can be done in two ways. First, using trigonometric form. Second, using complex form. So we can use either these two techniques for us to expand a certain periodic function using Fourier series. Okay, and in the trigonometric form of Fourier series expansion, it can be divided. Either we can use general formula of the Fourier series expansion, or by identifying the function, the periodic function, whether it is odd or even, so that we can use other formula which is simpler than the general formula. Okay, so that's all for the definition or introduction to the Fourier series expansion.